Okay, so today we're moving on and we're going to start talking about these things called arrays. Up to this point, if I said, I want you to read in 3 test scores, you had options. You either read them in and stored them in test 1, test 2, and test 3, or you read them in and added them to total or did something you didn't need to store them. Okay, so the options were, do I store them because I need them, or do I not store them, use them right away and be done with it? Okay, now I have to stop saying okay, I just realized I did it twice. What if I wanted to read in 100 scores? They're all scores, they're all integers, they're all the same data type. I don't want to make up 100 variables, but I know I need to store them because I want to use them throughout the program. That's where these things called arrays come into play. And they will allow us to set up a way to store all of these values so that I can keep using them throughout the program. Now, an array is similar to something that we talked about before in a sense, and that something is a string. And when we talked about a string held a memory address, and we would then go to that memory address and we would go a character at a time across that memory address until we found some invisible character that we really didn't talk about that says, whoop, we have the end of the string. So a string went to an address and stored characters side by side in memory until a certain end point. Well, an array is going to be similar to that, but I'm going to be able to store something other than characters. For example, I might want to store integers. When I get ready, I'm going to declare my array by going int square bracket, because that's how we reference an array, is with these square brackets. And the numbers we put inside of those square brackets are called subscripts. So when I go to declare an array, I'm going to say int left square bracket, right square bracket, then my array name, numbers. And the actual numbers is going to hold a memory address, but we don't need to worry about that right now. That's going to come up in for those of you that are taking the next class. So numbers equals new int square bracket, and now I'm going to give a size of 5. This is sort of looking familiar. Again, we've seen this data type and then a variable name equals new data type. We did it with our classes. So I'm sort of instantiating an object kind of the idea. But in this case, I'm declaring an array of integers. So the computer says, okay, numbers is going to get a memory address. And I'm going to start right here at the first memory address location. And I know I'm storing integers. So 4 bytes is going to be allotted to store the first one. 4 bytes will be allotted to store the next one. So it needs to find an area of, well, let's see, when I declared this, I said int subscript 5. I want to be able to store 5 values. 5 times 4 bytes would be 20 bytes. So I need 20 bytes available to store these 5 numbers. The first one is going to be stored in numbers sub 0. So in my square brackets, I put the 0. Sub 1, sub 2, sub 3, and sub 4. So when I declare an integer array of size 5, I'm going to be using the subscripts 0 through 4 again. And like I said, they're stored like mailboxes, side by side to each other. All right, so if I said, hey, I want to get the number stored in number sub 2. Well, what does that do? Well, that gets ready and goes to the memory address numbers and then goes 2 times, let's see, these are integers, so 4 bytes, moves over 8 bytes, and it's going to get that value that's stored there. So by using subscripts, it allows me to move across through my memory to the location that I want. Some examples, x equals, assuming x is an integer, x equals numbers, square bracket, 1 square bracket. So it's actually like an integer variable at that location. I could say numbers sub 3 equals numbers sub 0. If I try to use numbers sub 5, I didn't allot the memory for a fifth one. This could be junk. This could be the start of something else. In Java, it gets excited and says, whoop, whoop, I have an exception out of bounds error. So if you get an exception out of bounds error, that means you're not within the limitations of the memory that you set up for your array. All right, so I have a comment now, loops, loops, loops. Because to go through this array, we're not going to be going through very many individual locations. We're going to be going through all of them. And the way to go through all of them would, in fact, be like a for loop. So when I say chapter 7 uses chapter 4, which was loops, this is what I'm talking about. If you don't know your for loops, makes it hard to do chapter 7. So for counter equals 0, counter is less than 5. So that'll give me the numbers 0, 1, 2, 3, 4, counter plus plus. I could display to my console system.out.println parentheses numbers subscript counter. And that would be a way for me to print out everything that's in the array. So we're going to keep using arrays to work our way through all the items that are stored. And we're going to be using loops to go through all the items that are being stored in our array. Okay, so that was an example of outputting an array. What if I wanted to input in an array? Well, I could use the same kind of for loop and read numbers in and store them right inside of my array. That would be one way to fill an array. A second way to fill it, instead of using user input, would be to fill the array right away. And that's known as implicit initialization. I have an example, int, left square bracket, right square bracket, days equals. Now, instead of saying new, int, so on and so on, I want to fill it with values right away. So I put left brace. So this is like set notation. And then I'm going to put 31, 28, 31, and put in all the numbers, 30, 31, 30, 31, 31, 30, all the way out. So I've now filled an array with values right away. And you notice that I didn't put any size inside of here. And the reason is because I'm filling it right away. The size of this array is, I would need to go through and count 1, 2, 3, 4, 5, 6, 7, 8. I have 9 numbers in the parentheses. So the size of that array would be of size 9. And I would be able to use the subscripts 0 through 8. A nice function that's included with arrays is the one called number. And I can use it in my for loop. I have an example here for counter equals 0. Counter is less than numbers, which is the name of my array, dot length. Now you notice after the dot length, so many times we went dot length. Oh, that's a method. I need parentheses. There's no parentheses. Okay, counter plus plus. Just a reminder, at the end of that for, don't put a semicolon because that'll end that line and be done. It won't do anything. So when I was actually writing this up, I put the semicolon in and I went, oh crap, and I couldn't erase pen. So I put a big red there, no, like it's a teaching point. So that kind of works out. The implicit initialization, something you typed up in code listing 7.4. Was there any questions about what was in code listing 7.4? So you actually saw an example of it. Code listing 7.6 was an example that used the dot length. And a lot of people will use it. And it is common in a lot of languages to be able to find out what is the length of that array by using the array name and some sort of dot length. So it's something that's a handy tool to have, especially if you don't know the exact size of the array for one reason or another. Okay. Good. Moving right along. Copying arrays. Say I had 2 arrays, and one of them was called array 1, and the other one was called array 2. Well, if you remember, array 1 was actually storing what inside of it?
A reference.
Oh, yeah, a memory address, a reference to that starting location. Array 2 would have the address of its starting location. So if I was to draw something like this, I'd have array 1, and it goes to the start of a bunch of memory blocks. So I have a rectangle and I have, like a rectangle with little lines down through it. If I have array 2, it's going to a whole bunch of memory blocks, location in memory. So now if I said the line array 1 gets the value of array 2, what happens is array 1 would no longer store the address of what we wanted array 1 to be. It would actually get the same address as array 2. So now array 1 sub 0 would be the exact same thing as array 2 sub 0. They would both go to the same location. So we don't want to do that. That's a no. Don't, stop it. That's a no. So if I wanted to copy everything from array 2 into array 1, I'd have to go through this where for counter equals 0, counter is less than array 1 dot length, counter plus plus. Array 1 sub counter is assigned the value of array 2 sub counter. So I'd copy each one individually. I don't know of many situations where you want to give these arrays the same address, because that could really, really mess you up. Questions from any of the first few code listings? And I know a couple of you are like, woohoo. I'm like, why are you woohooing? Because before class today was the deadline for the last code listing. Code listing's done. What do you have left? You have 2 programs and a final. Nice. But in order to do the 2 programs, we're going to practice a program today. This is actually a really good one to know how to do. And one of the things is when we do this, we are building for what we're going to do on Tuesday. So as you finish this up, make sure you save it. Make sure you post it so others in your group have access to it. But this is one I want you to make sure you really do today and hang on to it. So what I want you to do, I want you to read in 10 numbers and store them in an array. Good, done. First block. Then I want you to have separate loops to go through that array and find the largest number. I want you to have a separate loop. Even though these could be done kind of all in the same loop, there's a method to my madness. And you'll see on Tuesday what I'm talking about. I want you to have a separate loop to go through and find the smallest. And I want you to have a loop that'll go through and add everything up to get a total and then divide it by how many there are to find out the average. And then I want you to display everything, including those original numbers. Sounds easy, and it's not too difficult, but I'm dictating you to do it a certain way because we're going to build upon this in the next class. Okay, so again, you're going to read in a bunch of numbers. You're going to read in 10 numbers. You're going to store them in an array when you read them in. So that's your first loop. Then you're going to have a loop to find the largest. That's your second loop. The smallest, that's your third loop. The average, that's a fourth loop to display everything, including the numbers, which will end up with a fifth loop. So you're going to have 5 for loops in this program. And I know you're saying, we can do it easier. That's right. But for now, just do it my way. Any questions? Okay.